Hello everyone. So today we are going to work on this time of day system in our Unreal Engine 5 open world series. So now you can see the sun is rising from this side and its sun is moving across the sky, so you can see the shadows are changing according to the sun's position, and we should see sunset in a while. And sunset. Okay, so this is what we are going to work on today. So at the moment I don't have a moonlight or anything, so that's why it's completely dark. We will work on that in the next episode. For now, let's see how to get the rotation of the sun and make it work with it for a time of day system. Hello everyone. So this is what we have done so far in our Unreal Engine 5 open world series. So here last time we worked on the dynamic rain and thunder system. So as you can see, now the environment is getting darker and it will start raining and with the thunder in a while. So next thing I want to work on is, in this open world series, time of day system. I know that I have already worked on time of day system in Unreal Engine 4 open world series as well, but I want to rework on that in this Unreal Engine 5 series as well, and see if we can have any improvements or we can learn anything new. So yeah, let's get started. First edit. So this rain, thunder and BP weather, so these are the systems that take care of the rain and making the environment darker for thunder, so for rain, and then the BP rain thunder takes care of the thunders or lightning strikes. So basically, for time of day, what we want to do is adjusting the angle. Sun is over there. If I change this pitch, let me set it to 30, sorry, minus 30, it's over here, and minus 45, it rises up. So basically we need to change pitch. So pitch minus 90 means sun is directly looking down, that means no. So just like that. 120 means it's in the other way, over there. So the sun should be moving from, if I set it to 0, it should be here, 0 to minus 180, that's the daytime. So if it is 170, 180, it should be the other side. Okay, so I'll create another blueprint. BP time of day. Let me set it back to minus 30. So first we need a reference to access the directional light, and also note that directional light should be movable, otherwise this system will not work in the runtime as you change the angle of the sun. So here sun, it should be in the type of directional light object reference. Okay, now this has to be public so that we can access it. Let me place it here and set directional light. Okay, right, then I'll add another variable I, and this should be in the type of let's say integer. So I think it would be convenient if I use a 24-hour clock. So 0 to 24, like this. 0 means midnight. So then we need to convert this 0 to 24 into the angles. So if I assume 6 in the morning as the sunrise, then 6 a.m. or 6 to 18 should be the daytime. So let me add a function, update sun position. Let's just say update sun, because we are just changing the angle of the directional light, so it's not necessarily the position, but we see the change in position. So here, now we get the sun and get the time. So first I need to divide it 360 degrees with 24 to get 1 unit. To make things easier to understand, let me just draw an angle and draw a diagram. So this is 6 a.m. that means just 6. So the angle should be 0, and this is 12 noon, angle should be minus 90, and in the evening sunset angle should be 180 plus or minus. But our timer scale starts in the midnight, that means here. So here time is 0, 6, 12, 18, and again back to 24, and 0 means plus 90 in the degree of the angle of the sun. So I think we can start the calculation like this. First we need to multiply time by here 360 divided by 24, and then we need to add, sorry, not add, subtract from 90 whatever the amount we get as the result, and that should be the yaw component of the sun's rotation. So set actor rotation I don't need to change Z component to X component, so get actor rotation, just the rotation. Split X and Y should not be changed, X and Z should not be changed, Y should be the result of this calculation. Okay, now to test this, let me add this, call this function in the construction script. Right, I think it became dark because by default we have 0 as the time. This has to be public, so we can change it. If I make it 6, it's in the morning. If I make it 12, it's noon. If I make it 18, it's sunset. So see, now we can change it dynamically. Like this. So it's morning, night, 8. Okay, now the function is working. Now to make it dynamic, what we can do is here in the event graph, let's add a timer. Now I'll disable tick because I don't think it's necessary to update the sun in every frame. So let's add a custom event, increment, not necessary to be an event, this could be a function as well, increment time. So we can get the current time, add how much. Well, I think it would be better if we convert this into a float so that we can have smaller increments as well. Yeah, so we have to convert to float. Oh, sorry, this also needs to be a float. 90 float, right. Let me check if it is still working. It is. Okay, now get the time, add to whatever the amount that we increment, and then set time. well, I'll call it yeah. After incrementing the time, we need to update sun as well, otherwise we will not see the effect. Now in the event graph, start timer, set timer by function name. So I'll set it to looping and update every 0.1 second. Function name is increment time, and we made a mistake. The mistake is here I added increment as an input. So I'll promote to a variable time step, let's call it. By default it has to be, let's say, 0.1. This may be too fast, but we can check. And for now, let me disable weather, so that we can observe clearly the time of day system. So we can simply add branch promoter variable. I'll call it start rate enabled, and make it public. By default it should be false. Okay, rain enabled is false. Now rain will not happen. And where is the time of day? Let me put that also on the lighting. Okay, now if I set the time to morning, it's too fast. Oh, something is wrong. Here, changing the angle from 0 to 360 also works, but my logic is not that. It has minus values as well. Therefore, times 0 means plus 90. If I go back here, this is 0, this is 90, this is 180, this is 270, and this is again 360. Okay, so how do we do that logic? So if time is in between 0 and 18, we should add 90 to this. And if it is in between 18 to 24, we should add minus 270. This should bring us to the correct range. Now we need to select this. If time is larger than 18, if time is larger than 18, we should choose this, otherwise this one. Hope I'm correct. Let's test it. Here 6 morning, 12, okay, 18 evening, 17 means 5, 19, Okay. Okay, I think it's working. Let's test. Oh. I was under the flow. That's why I got this errors. It's night now, so we don't have any moonlight or any other light, so it's completely dark. But if I check the time of day, you see it's 19. It should soon go to 24. Can I just speed it up? It doesn't go past that. Ah, right. Another issue that I overlooked is this increment time. It's not enough to just clamp. We should get the modulus and divide it with 24, so we can continuously go from time around the clock. Where's the time of day? Is it downloaded? Okay, it's working. Now it should switch to 0. Yeah, it did. Let me slow down now, and something is going wrong again. What is happening? Let me check the direction right. Oh, okay. So these angles go wrong. So to avoid that calculation error, let me just duplicate, disconnect this Z and X component. So that should fix that issue. And I will look into how to have the X and Z components of the angle as well and do an update, but for now let's just do it this way. And I'll set the time step to 0.1 so that we can check faster. Okay. We are in the middle of the night now, and sunset, sunrise. Right, so we can stop this episode right here. And thanks for watching. As always, project files will be available for the download in the Patreon page. Link could be in the description below. And if you like to support my work, you can get the membership of the Patreon Club. See you in another episode. Goodbye.